Hi, Prem. Looks like it's just you so far. Maybe in the next few minutes we'll get some more people joining in. But do you have any questions for me today? Any problems you've been having? Cool. What might your questions be? I'm also definitely going to revisit the glass reshatter setup that we were looking at in the last session that we got partway through, but ran into a couple problems with and didn't get to finish. So, but I will first prioritize any questions that you or anyone else has. Okay, so Prem asked if you can use this work on your demo reel. Yes, you absolutely can use it on your reel. I know that, for example, at work, they do have a number of people that apply with the exact shot. So any sort of things you can do to vary it up to make yours unique would be beneficial. But it can absolutely be a helpful piece in a demo reel, especially if you put time into finessing it beyond, this 8 weeks. And especially if you include all of the layers that we're reviewing and over the whole entirety of the course. It demonstrates a pretty broad skill set. So yeah, I'd highly encourage you to put some nice renders together at the very end, continue to refine any weak spots, and include it. Also, another option is that you could rework the shot with a different building asset. So it would be fairly straightforward to just find any stock model of a building online, TurboSquid or elsewhere, and you could try swapping that in instead of the round building that we've been working on here, just to make yours a little bit unique and maybe give yourself a little bit of practice just with a different asset. See what sort of curveballs it might throw you. Yeah. Of course, also, if any of my students can feel free to send me a reel if you want any feedback on it. I'm happy to check it out and give you my input if you would like. I know we've had at least one student from the class before at DNEG's Greenlight program who then did a whole bunch of work for us afterwards. So it's, yeah, I'm sure he probably included his shot from the class as well and his reel. All right, but yeah, so like I said, fire away at any more questions that you might have in the chat. Until any more questions pop up, I'm going to revisit this glass shatter thing. Where we left off before, we were successfully detecting the hits on the ground and filtering those hits separately from glass shards colliding with each other. But we were having problems getting the bullet ignore attribute to work properly. And at the very end of the class, or at the end of the live session last week, I kind of was quickly trying a few different things to fix it and probably made a little mess of this. We don't need this geometry wrangle because I was just testing things to try to get it to work. I was experimenting with it again just before this session, and there's a very dangerous thing that I had set when debugging the issues getting this to work, and that was the overwrite attributes option on the RBD packed object. Now this will always pull the attributes from SOPs and overwrite your rigid body attributes. So for example, some people when setting up initial velocity might be inclined to put V in here. And what that means is that you don't just add in some initial velocity. That means if you have a velocity of 50 in X and 0 in Y and Z, that means it's every single frame, your velocity is being reset to 50, and the sim can practically never take over because you're exactly specifying the velocity of the piece. I'm sure the sim still factors in, but yeah, it's very it's obviously an important parameter. We need to use this to update our active values that we set in SOPs. But anything that you set in here will stomp on whatever you're doing in the sim. So when I was experimenting with adding bullet ignore there to see if it affected anything, as I was tinkering with this again, that prevented any fixes I was making inside here from working at all. All right, so there are a couple of things we can do to simplify this setup as well. One of the awesome things about Houdini is that there are so many different ways to tackle things. And in the last session, we used a whole bunch of code to filter through our impact data to find only the hits that were on the ground. We were querying the primnum and vex here. And we can make our lives a bit easier by doing some of that filtering on the points, not just doing it within the wrangle. So if we go to a frame where we have multiple types of impacts here, we could just drop in a blast node after that impact import. And then in the blast, I'll type other object primnum, because if you remember from before, that's one of the attributes that comes in by default with all of our impact data. We have this other object primnum here. So -1 means it's colliding with the ground, and some other value means it's the glass shard primitive with that number. So instead of querying this in vex, we can make it a little bit easier by checking to see if other object primnum is equal to -1. And we'll set that group type to points because that's a point attribute. And by default, this is deleting those ground collisions. So I'll just flip that to delete non-selected. And now this is only giving us our collisions on the ground. So we don't have to do that check in vex anymore. Let's simplify this whole thing. We don't need this comparison here. Yeah, we don't need any of this stuff. I'm just going to do this from scratch just so that you can get used to seeing it built from scratch. Maybe I'll just leave this first line intact here. I have this find attribute val function that I'm using to look up the primnum of each of these glass shards in our impact data here, which there's no impact data there. Well, let's bring it back here. So yes, this impact data is storing the primnums. So as we're looping over primitives in this wrangle, for each of these glass shard primitives, I'm looking for that number on our impact input. So there are two flavors of this find attribute val function that we've used throughout the class. Find attribute val will give us all of the point numbers from this input that where it finds that attribute value. And we can also use find attribute value count to just figure out how many times that's found in the input. In this case, I'll use that. So instead of grabbing the indices, we'll just create an integer called num found. And then I'll say if at num found. And whenever you do a conditional expression, this it's considered to be true if you put in any number that's not equal to 0. So 0 is false, and 1 through infinity are considered to be true. So this integer for the number found on those impact records is going to, we can just use that number directly. So if this has 0 found, then that's not true. It won't do whatever's in here. And regardless of whether this found 1, 2, 100, then this will be true. So then we can tag this. I'll say I at hit equals 1. You can even do this on the same line if you want, whenever you're just doing a single line of code based on a conditional statement. And let's see. So this is going to probably not tag anything yet. We can create a split SOP if we want to double check which pieces are considered to be hit. So I'll type in at hit equals 1. flip the group type to points. Now if we scrub through this, let's see, we're not seeing anything yet. We should. Let's go to a frame where we know we have pieces on the ground. Oh, I see what's going on. This is not a point attribute at this point. We're doing this in a prim wrangle, so we're creating a prim attribute. So I can get rid of that group type which is set to points right now. Leave that default. All right, let's still not working. Let's check the attribute values directly. All right, so this is not tagging anything as hit. We have a warning in our wrangle here. So if you middle mouse on there, sometimes it doesn't tell you what the warning is. My guess is that maybe because we didn't specify in this if statement what the attribute, oh, I see what the problem is. Here I'm creating a local variable that only exists within this wrangle, this int numFound. And then in this if statement, I'm checking an attribute called numFound. But that attribute doesn't exist. We're just using this local variable. If we were to say I at numFound instead, that would create an attribute on this geometry. And I think that, yep, sure enough, that would work. But in this case, it's really up to you whether you want to keep track of that info on every frame. In this case, I'm not going to bother. All right, so we've got that fixed. We have our hit pieces being detected successfully. And now let's process the collided pieces. Since we want to process the points, not the primitives. Let's promote that hit attribute down to points. So go from primitive to points, select the hit. And then on this process collided, we were using the shatter group. Instead, I'll put at hit equals 1. And let's scrub through that. And so as we were seeing before, the bullet ignore seems to not be working. Let's double check that the attribute's being set correctly, which should be, yep, it is. So one thing I was finding when I was tinkering with this is that it's not surprising that order matters in this multi-solver, although it's not necessarily intuitively obvious which order it should be. And I was pretty sure that we experimented with the order in the session last week. But sure enough, you can see that if we flip this so the SOP solver comes after the bullet solver, now it's successfully freezing those pieces. Whereas, you know, when you have it flipped with the SOP solver before the bullet solver, looks like bullet ignore is not working. So, with that change there, we've got that working. Let's double check that our hit num is being set correctly. Actually, we can check that outside of our DOPNet here. We should be getting a hit, let's see, what do we call it? Hit frame or something? Let me double check the SOP solver. I called it shatter frame, okay? So let's jump out of here. And I had set up this blast node at the end of the session last week, where we're checking for any pieces with bullet ignore equals 1 and shatter frame equal to the current frame. So let's template display our glass. And sure enough, you can see that this blast stop is only isolating. Oh, actually, I see what's going on here. So we do have a little problem where on every frame of the sim, all of the previously shattered pieces are having their shatter frame updated. So what I assume the problem is that in this DOPNet, once we set this hit attribute on our pieces, those pieces remain tagged as hit all the time. So after this subsolver runs on every frame, it doesn't erase that hit check. So all the pieces that had hit by this point on the next frame, they're still tagged as hit. So they're going to have bullet ignore set again and their shatter frame set again. I'm surprised that this minimum check isn't successfully grabbing the first frame at which it shatters. That seems like it would. I would think this min would avoid that problem, but let's try just deleting that hit attribute at the end of our solver. So I'll drop in an attribute delete. And let's see, at this point, hit should be on the points. Yep, doing a sanity check. It's right there. Let's delete that. And let's jump out of our sim again. And let's see if, Sometimes when you're debugging things, it helps to look at what's happening to just one piece. So in this case, I'm just going to isolate one of these colliding shards. So let's select maybe this one here. I'll flip this to delete non-selected. Connect our DOPNet to that, and let's check the spreadsheet. Tell this to always stay on top, which it is. All right. Now I want to look at what's happening to that shatter frame. So that starts, everything defaults to 10,000. Okay, looks like our shatter frame is being set correctly. Cool. So, but our blast stop looks like, trying to figure out if our blast stop is doing something wrong. It's very strange. So I'm just going to wire this single piece in the blast, the single piece we've isolated into our blast stop that is supposed to be isolating the currently shattering pieces. All right, so I'm guessing we just made some logic mistake in here. So we're deleting everything with, I see, we probably just have to flip this. So let's say we want things with, let's say we want to delete everything where the shatter frame is not equal to the frame. You can do this in 2 separate steps. So if we back off, let's remove this blast here. Okay, so that was a simple mistake in our blast stop. So I've changed it so that we're deleting only the pieces with shatter frame that is not equal to the current frame. And let's also delete pieces. Well, actually, that's probably safe enough because any pieces that don't shatter are going to have a shatter frame of 10,000. So in this case, this is a good enough check. You don't really need to check against the bullet ignore attribute. So one thing I like to add with these sort of setups, I've actually been doing just this very exact same thing recently. And I started to add this in last week's session, is this reshatter attribute that lets you specify a percentage of your pieces that will shatter on impact. So I think what we set maybe 50% of these. Yeah, in the previous session, we set this reshatter equal to this check where we check to see if the random number based on the point number as a seed is less than 0.5. I'll paste that into the chat just in case it's hard to see. So that will tag, whoops, wrong command, copy this. So we have approximately half of them set to reshatter. So let's check in our DOPNet against that reshatter attribute. So on our detect impacts, instead of just checking to see if none found is greater than 0, I'm going to add on to this and say and I at reshatter. And this is another thing, we don't have to put is equal to 1 in this case either, because if it's 0, then it won't reshatter and it'll return false. Otherwise, 1 equals true. So in this case, let's also bring back our coloring. Actually, no, I'm not going to bother with the color right now. So we should see, yep, sure enough, you can see some of those pieces stay alive. Maybe it's a little bit hard to see with the ground plane there. Let's just display the DOPNet output. But yep, sure enough, half the pieces are reshattering and half of them are alive. So for all of the reshattered ones, we have this blast stop that is just isolating the pieces that are shattering on this current frame. And we're going to run a secondary sim. I'm going to unpack all of those pieces. And typically I would cache these out separately. So I would say, right now we're being careless and we're just kind of directly grabbing the geometry. I would certainly cache this out to disk. I would create points to represent these objects. Cache out this as a primary sim, and then use that cache result to run the secondary sim for the reshattering. So we're going to start by unpacking this because we want to scatter some new points on these reshattering pieces. So let's scatter. We want to do this based on density because we want these glass shards. We want the bigger ones to shatter into more pieces and the smaller ones to shatter into fewer pieces. And you can see how by default this scatter is placing all of those points at the edges of that geometry due to that relaxed setting. So let's just turn that off, get a bit more of a random result, and let's instance some pieces onto those new points. So we can grab the same setup as before, do a randomize n with the p scale. We can keep this normalized thickness, I suppose. Yeah, we can copy the same copy stamp. Yeah, all this stuff we should be able to use as is. All right, connect our points to that. And right now you can see that these pieces are far too large. These are the piece scales that we used for our initial sim. But since we're reshattering these pieces, they need to be significantly smaller. So on this P scale randomize, I'll just set that global scale equal to, looks like maybe 0.1 is too small. You can kind of play around with this to your liking. I might want this to reshatter into more pieces than that as well. So let's turn up the scattered density. That looks like it should be pretty decent. Maybe I'll template display those pieces that we're shattering to see what that looks like. And this sort of effect works well because you don't have to have these things break apart, in a way that exactly matches their current shape. Because over the course of one frame, you're going to have this complete shard hitting the ground, and then the very next frame, you're going to have these motion blurred streaks shooting away from that from these new RBD pieces. So you're never really going to notice that it's not exactly the same shape that's being emitted. So let's do an RBD emission based on this. So I'll drop in a new DOPNet, connect these new scattered pieces to that. But in this case, we only have the original instance piece names here, and we want these piece names to be unique. So let's set a unique name on those. And right now our name is on prims, so let's push that back down to points. So original class primitive, new class point, and select the names. And on this new wrangle, I'll call this unique names. And then in here, we'll just append the frame number. So s at name plus equals, I'll add an underscore and an F for the frame number, if I can type. So plus I to A, and I'll grab the wrap the frame number in a rent function that rounds frame to an integer value. So that adds the frame, but those names still won't be totally unique. Let's see, what does it not like? Implicit cast from float to int. I guess it likes using an integer cast more than a rent in this case. That's fine. This is also not going to give us unique names yet though, because you can see we still only have 20 unique names. So I'm just going to add the point number as well. So plus underscore, and then I to A of at ptnum. So now we've got unique names here, and in our DOPNet, we can use our same setup that we've done before. So a bullet solver and some gravity. And we'll add in our ground plane again. Merge those together. You can shift R to reverse the inputs on that merge. And we need an RBD packed object. Connect that to the bullet solver. All right. So in this case, if we want to emit those glass shards, since we don't have all the shards existing on our start frame, then we're going to have to change the creation frame here to be $F to emit those on every frame. If you want to, you could start with all of those objects existing and not emit them. So we could accumulate all of our source glass pieces. So here, if we scrub through, let's get rid of our template. So we could accumulate all of these glass pieces so they all exist at the beginning of the sim. But in this case, I'm just going to keep this as an emitted RBD. So let's dive inside. Control-Shift-Click that creation frame to break that link. And we'll just set this to $F. Rewind that sim. Turn off point display. And let's turn on smooth wire shaded as well to make those shards easier to see. Of course, we haven't actually pointed this at anything. Geometry source is first context geometry. All right, so now we're getting these glass shards added upon impact. So it looks like that emission is working properly, but we're going to need to set some initial velocities on these. So let's turn on inherit velocity. And we can, in this case, we probably could just give these all a bit of a random radial velocity. You could fully randomize it in positive y and x and z. If we want to, we could also, typically I inherit the velocity from the impact data for this. And this won't be as obvious if our pieces aren't shooting to the side. Let me double check the motion of those original pieces. Are, yeah, they're kind of going straight down, which is okay. We can exaggerate that initial velocity a bit just to make the inheritance for the secondary glass sim more obvious. So for here, let's just increase that positive x a bit. Maybe give that a velocity of 20. All right, cool. Yeah, that's a lot of variance in there. All right. So now let's go back to our impact data, and we should have a hit velocity attribute. So let's dive back inside here, go back to our SOP solver, and let's bring up the spreadsheet for our impact data. Let's scrub through until we start getting some of those impacts. And let's see what attributes we have at our disposal. Now you could use the impulse attribute, so perhaps you only want to turn off pieces, set them to bullet ignore and hit if the impulse is greater than perhaps a value of 1. In this case, we're getting values from 0 up through 3. I'm not going to bother with that now. Just looking, there should be a hit V or something like that, I believe. We have time, record name. This UV could potentially be useful for some things, so you can know exactly where it's hit on an object. Primnum position. I could have sworn we had velocity data here. Maybe I'm wrong. In any case, we could get the velocity data from the output of our primary sim. This is another one of those things where, because I'm used to using custom tools at work, some of the little features that our tools have, I mean, it's really not much different the way we work at work. It's all of the destruction setup is the same, so I wouldn't feel like we somehow have a better system. It's really most of the work for a destruction shot is all happening in SOPs anyway. So really, all of this stuff is really the same. There are just a couple little convenience things here and there, like a couple things to help sort through your impact data and that sort of thing. I could have sworn there was some sort of velocity included here, but I guess not. All right, in any case, that's fine. If there is, and I'm just somehow missing it, then you can use that. But if assuming I'm correct and that there is not, we can just use the velocity that came from the sim. So for all of these collided pieces, we should have some velocity data on them. Let's go to a frame where we have some of those. Let's template display our primary sim. Go to one of these shards that would have a significant amount of velocity over here. And on this unpack, let's also transfer that V attribute and display point velocities. Are we getting velocity here? Sometimes all these attributes that we get with our DOPNet can be a bit overwhelming. So I'm just going to delete a lot of them. Actually, instead of doing an attribute delete, you can use the regular attribute SOP. I think it's just called attribute. Sometimes I just drop it in with a rename. But I think, yeah, I thought there was just one called attribute. In any case, this attribute rename SOP gives you an option for keeping specific attributes. So let's say we want to delete everything and set keep to blank. So that's removing all of our point attributes. And then we can select from our dropdowns which ones we want to maintain. So maybe I'll keep velocity. Let's keep, what else do we need? We need the name, maybe the name orig, and we definitely need our shatter frame. There's that. Let's keep our angular velocity W. Most of this other stuff we probably won't need. We can always bring it back if we find we do need it. But yeah, let's stick with that for now. All right. So now we're isolating just the colliding pieces here. Wait. Oh, looks like, let's remove that delete attributes option. Okay, so it looks like this keep at, I don't usually use the attribute rename. I've been starting to once in a while use this. Usually I'll just use attribute delete. But yeah, so if you want to specify attributes to keep with this SOP, you don't need to set anything in delete. You just pick the ones that you want to maintain there. So that's throwing out all that extra stuff we don't need. So now our blast should work properly. Let's check the velocity values here. Okay, we are getting some good velocities. Now on this unpack SOP, I'm not seeing any, whoa, I don't know why this got set to -18 iterations. Let's set this to 1. So yeah, somehow, I don't know if I was just getting careless with my mousing around, but when we have that iteration set to -18, that means it's not actually unpacking it. So you can set that back up to 1, or just uncheck that to unpack this as many levels as is needed to get regular geometry. So now we can see that this is picking up the velocity from our sim. That's all good. And we can use this velocity, excuse me, use this velocity for the initial on our reshattered shards. So probably don't need to do anything else. The scatter will automatically inherit that V attribute, like you can see here. And that will follow through, should follow through onto our pieces. Let's double check if we're copying that over here. It looks like, yep, that's picking up that V attribute. So now if we check our glass emission sim, let me just save this in its current state, just in case we have any crashes or anything. All right. And in this .NET, I'm going to change the object merge to just RBD star to give us that RBD packed object. All right, cool. So now we have those emitted shards picking up the initial velocity from those pieces. Let's view everything together in context to see that all at once. So this blast SOP here is isolating the currently shattering shards from our sim, like so. But we're going to want to render our original shards with just the shattered pieces deleted. So we'll need a slight variation on this blast SOP. Instead of just isolating the pieces with that are shattering on a current frame, we're going to set this to blast away everything with a shatter frame that's less than or equal to the current frame. So here, you can see everything's maintained, and then they just disappear once they shatter. At least I think they are. Let's check the point count. We have 69 pieces out of the original 125. All right, so that's working correctly. And now let's merge that with the output of our second sim. Merge this down here. Typically, I would put these into different render objects, not just merge them together. Really just merging them for the sake of, just viewing it. And cool. And this effect does hold up well up close as well. So So even though it's not like we're constraining shards together and releasing those constraints, it still looks pretty convincing. Let's see if it plays at speed here. It's looking a little bit too bouncy. We have to fix our parameters here. And it looks like our collision shapes are probably bad for some of these. We probably set no spin max or speed max or the acceleration versions. So there are lots of artistic tweaks we need to make like that. But just in terms of that reshatter effect, looks like it's working well. And this sort of thing where you have a certain percentage reshattering on impact is something that gets heavily commented on at work. So they're often asked to have a pretty specific amount of these shattering or maintained. So if we want to make this shatter a few more of those, so only a few of them are intact, we could perhaps go back to our wrangle for the primary sim, our original sim attributes, and have that reshatter if that random number is less than 0.8. So if we rewind, and you can see this is a super fast sim as well, and play through that, you can see it looks like, wow, we have some crazy behavior. Yeah, it looks like fewer of those pieces are preserved. So it's a nice art directable technique. And you could also emit constrained together pieces, but with glass in particular, if you wanted to do this with pieces constrained together, breaking up when they hit the ground, it might not work well because if you have these pieces pre-broken and constrained together, then you might not see it in the motion blur, but you will have cracks all through these glass shards. And especially if it's slow motion or something, and you actually can tell the difference. Even if it's not slow motion, you can often see these details, but you might not want those cracks to be visible until it reshatters. So it's just another bonus reason for setting it up this way, instead of just constraining them together and having those break up on impact. Let's maybe dial in some slightly better settings here. Let's see, we're setting, let's set an Excel max on our reshattered pieces. Right now we're currently setting no sim attributes. So this unique names for the reshattering, I'll rename that to just sim attributes in general. I'll set an Excel max there. Of course, we can also artificially change those velocities. We don't need to just rely on the velocities from the previous sim. For example, maybe we'd like the general behavior of this with those accelerations limited, but we want them to just pop upwards a little bit more. So we could just artificially add in our sim attributes here at v.y equal to, actually let's not do it here. Let's do it in a randomize. So drop in an attribute randomize, and I'll set the attribute name to v. Dimensions should be 3. And for the operation, instead of set value, we're going to add value. And for x and z, I'm just going to set this to 0 for both the min and max. And for y, I'll try adding 0 through 5. It might be a little bit too extreme, but see, that's not very noticeable. Let's see. If you're ever wondering if a sim attribute is simply working or not, you can just try adding some crazy values. Like let's add 100 for both the min and the max to the y. And let's make sure our sim is resetting. I'll rename that to .NET Reshatter. And let's reset that. All right, so yep, looks like our .NET was just not resetting the sim. So The velocity of 100 is doing some crazy things here. We don't want that. Let's set this back to something a little more reasonable. So yeah, that's something to watch out for. Sometimes when you change these upstream nodes, it won't reset the sim. So if you're not seeing behavior you expect, I would just watch out for that. So now, I'm still not seeing much. As you're well aware, tweaking these settings can get a little bit time consuming. There we go, we're getting a little bit more there. You get the idea though. I won't spend too much time trying to tweak these unless, anyone here is really interested and seeing me dial in, all the right bounce settings and speed limits and etc. I think I will though double check the collision shapes for some of these, because a lot of these pieces are rolling around quite a bit, and it's important to remember this issue because it can pop up pretty often. This issue with the collision shapes being rounded off. So in this reshatter, I'm going into the RBD packed object bullet data, turn on show guide geometry, and you can see that, especially for some of these smaller ones, that convex hull it's using is kind of rounded off. So if you shrink that padding value, it gets a bit more accurate. You probably need to refresh. So yep, if you rewind your sim and jump back, you can see that just cutting that in half to 0.01 is giving us some better shapes. Supposedly, this sort of padding and shrinking is, my understanding is it gives you some slightly better results out of objects fractured at a normal scale. But so I'm not really sure if there are downsides to setting this to 0, because you would think that with no collision padding and no shrink amount, you're just going to get much more accurate convex hulls. And I'm sure there's some rationale to setting this to that slight approximation. Maybe the solver just likes having those slightly rounded edges on things. So yeah, I don't know, that's something worth experimenting and maybe investigating a little bit further. But in this case, you'll see that 0 makes the convex hulls match almost exactly. 0.01 looks close enough. So that should be a decent setting for this. And of course, we can do other types of secondary effects too, not just reshatters. We could perhaps do a volumetric thing. So one thing that can be extremely helpful, especially for shots where you have, maybe lots of things happening all over a scene. Let's say maybe you have a wide battle shot where you have some things shattering over here and some bullet hits over there and etc. And you just have tons of things happening. You wouldn't necessarily want to sim everything in your scene. So you could use some instanced volumes for these things. So let's try setting up a basic volume instance. So let's what's the best way to do this? How much time do we have? We only have 10 minutes, but we can see how far we can get. Actually, I'm trying to remember what's the best way to do volume instancing. Usually we use custom stuff for this as well. I've done some pretty hacky things for it before. Yeah, maybe I'll save the volume instancing for next session, just so I can make sure it's nice and smooth. I think it's going to be too much to tackle for the 10 minutes or so we have now. But yeah, depending on what the object is, this can be any number of secondary effects. So maybe if you're doing some sort of a metal effect, you could do some sparks off of these isolated source things here, these per frame impacts. Yeah, so let's see, what else can we go over in the time that we have left. If you are interested in seeing volume instancing thing, let me know and I can take a look at that for next week's session. Also, I don't suppose anybody in the class is from Japan, but I'm going to be in Japan from the 6th through the 13th, talking in Nagoya and Tokyo and Osaka. So if anyone happens to be from there, feel free to, I believe the info is on the IndieZone website. Feel free to check that out. I'll be talking about some various destruction tips and tricks, and etc. And yeah, it's always cool to meet students in person at conventions. You know, put a face to the name on the website. So, let's see, what else can I show in the next few minutes that I have here? Never want to start on too much of a heavy thing when we have a brief amount of time left. Let me just consult my notes to see if any of these things jump out as good quick ones. Oh, I know what we could do. Yeah, we could take a look at adding an extra dust layer coming up from the ground. So let's go back to our normal shot render camera. Let's bring back our proxy version of the buildings. I'll set this to manual. I'll make sure that this week 5 post-sim tweaks is showing us the proxy version, which it is, okay. Let's display that. Now, you know, week 8 focuses on, oh, sorry, yep, it looks like Prem has a question. Fire away, what might your question be? Just while I'm waiting for that question to come in, oh, are there any VFX companies in Japan? I don't know, you know, what the Japanese studio market is like. I know there are some pretty big games companies. I think I'll be stopping by a couple, you know, production companies there as well. So I'll probably know more about the Japanese market after this trip coming up. As it is, I don't know of any big ones there, but yeah, I would not be surprised if there are. I would think there would be some decent amount of work to be had there. But yeah, I know there are definitely a few big game companies, like there's Capcom, Square Enix. But yeah, won't pretend to know the market very well in general. So I don't think I'll have much time to go very far with this extra element that I was just going to discuss. But just to give you an idea, you know, week 8 focuses on dust, and we're concentrating on the dust coming from the building, and we're calling out all of the dust off screen because dust is very slow to simulate and render, and these VDB caches can be quite heavy. I can't remember how big my caches are. They're pretty massive, to be honest. If you're curious, I'm sure you probably are. I've got too many windows in the way here. I desperately need some new disk space, as you might be able to tell. Let's go to the caches, the dust. That's not the right one. Just to give you an idea of what mine is stacking up at, my dust cache for this shot was over 80 gigs. And that's with the volume calling to remove everything off screen. But that said, you know, sometimes we'd expect, especially for a big shot like this, perhaps to have some dust blowing up from the ground. Because this is, you know, this massive amount of destruction, I'd expect to maybe create a bit of a billowing cloud down here. And that could be a really nice addition to your shot, especially if you're looking for ways to kind of spice yours up and maybe make yours a bit different from the other students who have been working on the same shot. And to do that, I would certainly do the extra dust from the billowing up from the ground in a separate simulation. So just to give you an idea of how you might source that, let's create a new geometry container, dive inside, and there are so many different ways to set up everything. You can feel free to get creative with how you source things in general, but let's maybe use some placement spheres. I'll just move a couple of these into place since I'm trying to fit in a little bit of this real quickly before the session's over. I'm not going to be very precise about this. Let's scale that up, and I'll just convert this to VDBs. Now you could maybe just use this. Oops, don't want convert VDB. We want VDB from polygons. You could potentially use this directly as a source, set a fog instead of a surface. Maybe add some noise on there. But if you want to, instead of just using some sphere as a source like that, it might be nice to scatter some extra points within that sphere. So let's hook up a scatter there. Maybe scatter 12 points, turn off the relax, and maybe copy some spheres to that. A lot of the nice features and behavior of dust come from building some decent sources. So anytime that you can add some more interesting noise to kind of break up your source volumes, that can make the resulting sim a bit nicer. Let's just copy some spheres here, like so. Make those polys a bit bigger. And be able to mountain this up a bit. And for this sort of thing, it might be worth looking at maybe some procedural cloud building tutorials. This whole thing looks like it might be a little bit too tall. I know I said I didn't want to spend too much time getting this just right. That'll be fine. So let's convert this to VDBs again, VDB from polygons. Once again, we'll make this a fog VDB, and we'll add some noise. Actually, let's use the pyro source. Do pyro source to create the points here. We'll set the mode to volume scatter. Increase that particle scale a bit. Maybe we'll jitter that a bit as well. And let's do a rasterize volume from that. Oops, sorry, we don't want volume rasterize. That's an easy mistake to make, I think. At least I don't think we would want to use volume rasterize. I've never used this one, as far as I remember. It's easy to get that confused with volume rasterize attributes, which is the one we want, because that will allow us to rasterize our density. At least it should. Do we have a density? No, we have no density attribute yet. So on this pyro source, if you add one attribute, you can select density from the dropdown, and that will give us this fog here. Looks like that's a bit big. Maybe I'll turn down this particle. If I turn down the particle scale too much, you can see it gets too spotty, which probably doesn't look nice. So let's not do that. When you build this from a pyro source, this is automatically setting a p-scale attribute for you that you very possibly could use as is. And as we've done before, we'll create an attribute noise. And let's noise up the density. Turn on these scene lights here. Anyway, you get the general idea. I would break this up. We could try both multiplicative and additive noises. Let's see. Yeah, that's probably good enough. We can set the signature to 1D. Maybe remap that from 0 to 3 or something. Yeah, you can play around with this to build a nice source. But then to simulate this, there are lots of different options. You could use velocity fields. In the week 8 content, I don't know how far people would have gotten so far, but I'm using a velocity field to help push things down because I wasn't getting the results that I wanted out of gravity and buoyancy. Typically, I would try gravity and buoyancy first before trying the extra fields. So let me just bring up my pen tool. So what you could do is you could use the temperature to cause this extra source to rise up a little bit, because it might be nice throughout the short to have this kind of billow up for the first half and then start to fall down. So see, you could animate the buoyancy throughout the shot. You could potentially use some temperature with some fairly rapid cooling to cause that to rise, due to its temperature, but then using the cooling and the pyro solver, allow that to cool off pretty quickly so it stops rising, then can just fall with gravity instead. You can use both buoyancy and gravity, and of course you can just use velocity fields as well. You could just have a noisy velocity field pointing upwards for the first half of the shot, and then animate that direction so it kind of comes to 0 and then points downwards for the second half. These are all valid options for controlling that sort of thing. But in any case, however you do it, that would be a pretty nice addition to the shop. So yeah, hope all of this stuff is interesting and helpful for you. As always, if you have any questions or problems with this week's assignment, feel free to send me an email or post on the forums, because as always, if you're running into a problem or a question, there's a good chance that other people will as well. Always good to benefit from each other's questions. And yeah, good luck with this week's assignment. And I know the dust is always a challenging one. It is pretty time consuming sim-wise. And yeah, it's definitely one of the more challenging parts of a destruction shot. And yeah, I'm sure that, with the information available here, you can get a very good version of that done this week. But I would be prepared if you want to really refine it nicely for a final piece that you might want to spend some extra time beyond what you have available this week to really dial that dust in nicely. Yeah, good luck with everything, everyone, and I will look forward to seeing the updates on your homework assignments.